This is a counting circuit. It counts up in binary and decodes and displays its output on the 7-segment common cathode display. Unfortunately, several issues occurred, and due to a lack of time, I will instead show the circuit visibly functioning up to its binary output. The circuit requires a clock signal as an input to the counting ICs. A clock signal is a signal that oscillates between a high and low state, as seen here. To create the clock signal for this circuit, we use a NAND gate oscillator, which is made up of two main parts: the four NAND gates it uses as the processor, and the two RC pairs that control both frequency and duration of the clock signal after the PBNO has been pressed. The 4017 takes the clock signal used from the NAND gate oscillator as its input. Every time the clock signal goes high, the 4017 will count up and output on the pin corresponding to the number it is currently at. Once the 4017 reaches 10, it resets back to 0 to repeat. In the full counting circuit, we will wire the divide by 10 pin to the clock input of the binary up and down counter, which will also decrease the speed of the counter since the clock signal now needs to produce 5 highs before the value increases in binary. The 4510 binary up and down counter is the IC we use to count for the final circuit. It outputs on 4 pins corresponding to the 4 bits of binary it is counting with. The outputs are wired DCBA to the input pins on the 4511, which will decode the binary, and when wired to the 7-segment display, show the binary values in their decimal equivalent.